Assalamualaikum and hi, my name is Putri Farah binti Effendi from Group 10. Now I am going to show the validation of our calculation from matrix iteration method by using ANSYS Software. So this is the free body diagram that we draw from the theoretical calculation part by using standard matrix iteration method. So we know that the value of mass 1, mass 2, K1 and K2 are given from the question. So we assume that our structure are from steel with the density of 7,850 kg per meter cube, and we get the value of dimension by using the volume formula. So the first step is open the ANSYS software and select model to draw the geometry in the design modeler interface. Choose XY plane and start doing the sketching for mass 1. Remember to change the unit to millimeter. To sketch, select rectangle to draw a box for mass 1. After sketch a rectangle, define the dimension by selecting semi-automatic option. Now define the dimension by insert the value of dimension x1 into the column. We also assume that the value of distance from the ground to the base of box is equal to 150 mm. As the sketch is complete, we need to extrude the box and select apply. And we need to change that the box is both symmetric and the depth is half from the dimension. So we generate. So we can see that this is the box for mass 1. Next, we create another sketch using the same steps by changing the dimensions x2 for the mass 2. Now, we open the model interface, then checking for the material and make sure that the structure is a steel. Next, we add a connection, which is spring. But before that, we need to make sure that the unit is in a matrix form, which is Newton per meter. So we put the value of stiffness, K1 is equal to 250,000 Newton per meter. For the scope, we change it to the body to ground. Select the face of base for mass 1 and select apply for the spring to appear. After that, repeat the same steps for the second spring using two faces on opposite of each mass with longitudinal stiffness K2 equal to 650,000 Newton per meter. Generate mesh and insert the remote displacement data. Select mass 1, then set Y direction to be free and other direction as 0. Repeat the same steps and make sure that Y direction is to be free and other direction as 0. Now, go to the analysis setting and set the maximum modes to find S2. Then, click Solve in a solution. So, this is the reading of first and second natural frequency that we get. Now, we want to see a mood shape. So, we need to select both of the value of natural frequency and create mood shape result. From here, we can see how the mass is vibrate and the mass of M1 and M2 is moved in the same direction. So for the second natural frequency, we can see that mass M2 move in an opposite direction of M1. So that's all for the first design. So for the second design, we need to repeat the same process but with a change of the stiffness K1 is equal to K2 equal to 650,000 Newton per meter. So to get the value of natural frequency, we need to solve it in a solution, and here is the reading of first and second natural frequencies that we get. So we can compare that the value of natural frequency that we get from the theoretical calculation and by using the software is a slightly difference. So here is the mood shape. We can see that the mass M1 and M2 is moving in the same direction. So for the second natural frequency, the mass M1 and M2 is moving in an opposite direction. That's all. Thank you.